Okay, hello everyone. So in this video we will see one question of your 2022 Gate Aerospace previous year question. Okay, so this is previous year question for they have asked for 1 mark. So this question is from your aircraft structure, specifically if I say more precisely from chapter called band. Okay, so this was a very simple question, kind of conceptual side. Okay, let's see this question what they are asking first. A beam with a symmetrical T-shaped cross section as shown in the figure they have given is subjected to a pure bending. That means only bending, we have no shear force, no shear stress. The maximum magnitude of the normal stress is realized at the top fiber of cross section, at the bottom fiber, only at the both top and bottom, only at the centroid fiber of the cross section. They have given 4 options. So they are asking it at what section, whether it is top, whether it is bottom, at what section the stresses, normal stresses or stresses will be maximum. So let me tell you that the normal stress also called it as in bending, it as a bending stress. So not to worry when they say bending stress, when they say normal stress, when they say direct stress. In the previous lecture I have discussed about this. Okay, I hope it is clear to you. Let's see and let's try to solve this question. Okay, if I tell you the basic equation we have for the bending in terms of this, so the cross section wise, this is cross section. Okay, for you, okay, let me try. Okay, this is the cross section. Axis is phi, this axis is x, and the length direction, and in this longitudinal direction we have a z axis, right? So the stresses induced when you apply bending moment like this, like this, stresses generated are in this direction, so which is your sigma z. Okay, similarly you will have a sigma z. Okay, I hope you got it. So bending stress, we write it as sigma z. So sign convention is very important, guys. You cannot write this as a sigma x, otherwise you need to change the coordinate system. You cannot write sigma y, you have to change the coordinate system accordingly. So I am taking it as sigma z, so according to the this. Okay, now this is the way to write this formula. I will tell you by the two method. Okay, need not to worry, you can choose any of this. There is a way to write this formula to remember, otherwise it's a lengthy formula, to it's difficult to remember all the time. Okay, so what you have to do, first you write x here, okay, and you write y here. Okay, then what you do, you write this I x and I y minus I square x y. Same thing you write in this, in the denominator, I x I y minus I square x y. I hope till this point is clear. It's easy to write, right? First x we need to write, then y, then this whole we need to write in the both denominator. Okay, it is clear now, because I am telling you how you can remember the formula, otherwise it's a bit difficult to remember. Then what you do, now you have x here, right? You have x here, so what you do, you write mx here. Okay, and the opposite moment of inertia you have to write Iyy minus, now mx is completed, now you write my, and here Ixy will come in both the side. Okay, now this term is clear. Okay, let me change this. This is y and this is x. So you have y, you write x here, then opposite moment of inertia will come here, then again mx is completed, then you write my, then always there is a Ixy, always there will be Ix in both the term. Okay, I hope it is clear. Now what you do, now I have y here, so I will write y. Okay, opposite moment of inertia of this, Ix minus, always there is a minus, then my is completed. Now I write x, all ixy will come here. Okay, I hope now it is clear how to write the formula first, because it's a bit difficult to remember this big formula. So okay, now let me tell you few things in this. This is moment of inertia about x-axis, this is moment of inertia about y-axis, this is nothing but your relative moment of inertia, and mx is moment which is rolling about x-axis, right? So if you see in the diagram, this is the moment is rolling, so this is the your coordinate, right? This is x, this is y, this is x. So moment is rolling like this, right? So which is rolling about x-axis, so this is mx. Similarly, you have my, which is movement is rolling about y-axis, and this is the variation in the y direction and the x direction. We will see what is this. Okay, now if you see ixy, which is relative moment of inertia, becomes 0 when you have a single symmetry or you have doubly symmetric cross section. So automatic your ixy becomes 0 in that case. Okay, so can I make it 0? Can I do this? Yes, we can do this, because this is already, because your T section is a single symmetric cross section, whether it is a single symmetry or double, ixy will be 0 in that case. Okay, okay, now the both this term is gone, so can I write now this? Now similarly in this we don't have my, right? We don't have my, so my also becomes, so can I do, yeah, in this we have this, yeah, my becomes 0 in this, so this whole term is gone. I hope you understand, this whole term is gone, whole term becomes 0. Now can I write this and this will get cancelled out, so only I will end up with this formula into y. I hope you understand what I have done, because in the question itself they have given this, they have not given this, they have not, because this ixy becomes 0, so we at the end we end up with this formula. Stresses in z direction will be given by this only. Now the main thing start from here, the whole essence of this question. Now if you see stress, let me draw that variation also, shape, then you will able to understand. Now this y, mx and ixx, you know this y, let me tell you this, what is y is the distance from the neutral axis, from the centroid of the system. Okay, so centroid will be somewhere, if you calculate centroid by the physical sense, centroid of the T section will be somewhere here, or if you have practiced this kind of question of finding centroid of different kind of shape, you know this. So this is y-axis and this is x-axis. Okay, now can you tell me, we have a y here, so that means our stresses will be varying in the y direction, that means in this direction stress is vary. So now if you see, now they are asking the maximum magnitude of the normal is realized what fiber, can you tell me now? Now your stresses will be maximum when your y is maximum, this is constant because of the, and this is also constant kind of thing. So now only thing you have to vary, this is y, so y, if you see, y will be, this is a y1, we say it is y1, and this is y2, and here if you see carefully, y2 distance is greater than y1. Okay, that means now can I say in this way, can I say in this way, that means normal stress will be maximum at bottom fiber. Can I say this now? Because the y is maximum at the bottom fiber, so I will get maximum stress at the fiber, right? So according to this, normal stress at the bottom fiber will be maximum. Okay, so according to this yes, B option is correct. Only at the bottom fiber, the bottom fiber of the cross section. Okay, I hope you understand why option B is correct. If you match with the key, I have put it key here. Question number 20, option B is correct, and this was asked for 1 mark. So this was the one method, and if you know second way, if you know the Euler-Bernoulli beam equation, M by I, and this is given like this, and E by R. I please correct me if I'm not wrong. This is the equation for beam equation. We many times say simplified beam equation. So according to this, you can also write in this way. Can I take these two component, and stresses will be M by I into Y, and when mx is only acting, so this becomes xx, and this becomes z now. So according to this, sigma z is proportional to y, so y2 is maximum, so at the bottom fiber again it will be maximum. So this was the two way. First one was this, second one was this. So mechanical people try to use this equation, aerospace people will try to use this equation. Both are one and the same thing. If you are assuming these two things, you will end up with this equation only. Okay, so I hope this is clear. I touched the basic thing, came up with all those concepts, and I try to solve this question. Okay, so I hope it is clear to you. If not, you can ask me in comment section. Okay, I will try to answer there. Let's meet in the next lecture with a new concept. Thank you.